Now in this video, we will start our discussion on wireless sensor network. Let's first understand the traditional wired system challenges, and then we will talk about the wireless sensor network. So in case of traditional wired monitoring system, the laying of the traditional wired system is very expensive because the communication cable installation requires the cutting of land and then digging up the required land and then install the cable. So it requires a lot of human manpower and money to install these kind of wired systems. So because of that, it becomes very expensive. Now, if there is a fiber cut or the communication cable is cut, then it is very expensive for the regular maintenance, because first you have to identify where the cable has been cut and then you have to carry out the maintenance. And creating joints in the communication network is also an expensive activity because it is not an easy to join the communication cables. Then next is the land acquisition challenge, because for laying the wires you need to have the land acquisition in place so that you can dig up the land and lay the wires. So because of that, it is not widely implemented today because it contains overall high cost. So what is the solution? So the possible solution is the wireless sensor network. Now it has the advantages like rapid deployment. You have to just install the devices and the network will be stabilized wirelessly. Low cost, flexible. Communication network is flexible enough to reroute the communication packets from one channel to alternate channel. Now aggregated intelligence via parallel processing. You can have parallel processing enabled in case of wireless sensor network. So it will give you a better data transmission as well as offering the intelligence in the data transmission. Now what are the various usages? The automatic measurement reading. So the field equipments which are very far from the say substation or maybe the measurement or control center, you can acquire data wirelessly and share with the processing systems. So remote system monitoring and equipment fault diagnostic is very easy if we deploy the wireless sensor network. Now let's talk in detail about the wireless sensor network. Sensors measure multiple physical properties and convert a signal detected by these devices into electrical signals. Whatever the parameters we want to sense in the field and the acquired data related to those parameters, we can utilize various sensors which can convert those parameters into corresponding electrical signal. Now these electrical signals are the analog signals. You can utilize analog to digital converter to convert these signals into corresponding digital format. Now wireless sensor network are the network of sensor nodes consisting of sensors to sense and control their environment. So for converting the electrical signals into digital signals and carrying out the transmission of those signals to remote server, you need the device which is called as sensor node. So sensor node consists of the sensors and the processing units to process the data which is received by the sensors. So we'll discuss these wireless sensor nodes in next couple of slides. Wireless sensor nodes are distributed in ad hoc manner, so you can distribute them in field. These wireless sensor nodes can be attached to various devices, and those devices will create a mesh communication network so that the data can be shared to the server. Sensors work with each other to sense some physical phenomena and process it to get the relevant results. Wireless sensor network communicate through wireless links, enabling interaction between computer and external environment. So the wireless links which are being created by these wireless sensor network nodes, they will send the data through wireless link to the remote computers or maybe the other devices which are responsible for the processing of the sensor data. Wireless sensor networks consist of protocols and algorithms with self-organizing capabilities. So we will discuss in detail what are the various protocols and algorithms are required for the wireless sensor network, and these sensor networks are having the self-organizing capabilities. So we will discuss in detail in next few videos, but for the timing, let's try to understand the self-organizing capability. So the self-organizing capability in case of wireless sensor network is a special property which allows the wireless sensor nodes to discover the paths for the data transmission. So if any node which is part of one data transmission is not working, sensor nodes are capable to reroute the data through some alternate transmission path so that the data is received at the remote server. So that kind of capability is called self-organizing capability, where they organize in such a way that they create alternate communication path for the data transmission. Now the wireless sensor network, you will see these sensors are part of our day-to-day life. So if you see an example of a smart city concept where all devices and equipments and the establishments are having various kinds of sensors for various activities. Say for example, smart road sensors will see the movement of various vehicles and they will switch on and switch off the traffic lights for the better movement of the traffic. Smart lighting, so the smart lighting will enable the automatic switch on and switch off the street lights and even the lights in the houses based on the ambient light. Similarly, other sensors like noise sensor or electromagnetic level sensors, traffic congestion sensors, or maybe smartphone detection sensors or air pollution sensor and so on. So a lot of sensors are deployed at various levels to acquire the required data. Say for example, in case of waste management, we have the smart bins which are IoT enabled and they sense the condition of bin. If bin is full, immediately this information goes to municipal corporation and someone will come to empty the waste basket. So in all those cases, the sensors plays major role for acquiring the data for better decision making. Now, wireless sensor network components. So wireless sensor network is a special type of ad hoc network composed of a large number of sensor nodes spread over a wide geographical area. So what are the various components of wireless sensor network? Here you will have three major components. One is sensor, then sensor node and the sensor network. Sensor means a transducer which converts one physical quantity into an electrical quantity. Say, for example, heat, light, motion, vibration, and sound are converted into the corresponding electrical signals. Now, what is the role of sensor node? Sensor node is basic unit in the sensor network which contains onboard sensors, processor, memory, transceiver, and the power supply. So they are responsible to convert the electrical signal into the digital signals, and then the information is processed, then maybe stored in the memory or transmitted over the network. Similarly, if the information comes from the remote end, they will receive the information and take action accordingly. Then third important part is the sensor network. It consists of a large number of sensor nodes which will create the sensor network. These nodes deployed either inside or maybe very close to the sensed phenomena so that the required parameters can be collected and then it is shared with the network. Now let's see the internal architecture of wireless sensor node. So here you have first the sensing unit. So sensor will sense the external parameter and then it will convert into the electrical signal. This electrical signal will be passed on to ATC, that is analog to digital converter, and then this information is given to central processing unit, that is composed of processor as well as storage. So it will process the data, store the information, and then it is shared with the transceiver for sending or for receiving the data. Now all these components which are there in the sensor node require power unit. So the power unit, which is a very important component of sensor node, is the largest component of the wireless sensor node. Why it is the largest component? Because the sensor nodes are developed in such a way that they can work for years, and for that you need the power unit which can supply power to the components for longer duration. So because of that, the power unit in the sensor node is kept little bit bigger so that it can last longer. Now sometimes we might have the power generator available. Say if the wireless sensor node is nearer to the power supply, so you can directly plug in those nodes to the power supply so that they can continuously get the power supply, and battery which is there in the power unit gets charged frequently. Now another component which is optional is the location finding system. So what is the location finding system? It is commonly required because most of the sensor network routing techniques and sensing tasks require knowledge of the location with higher accuracy. So this will provide you the information about the location of the wireless sensor node. We also have mobilizer which are required to move the sensor nodes for carrying out the assigned task. Sometimes we might need to shift the sensor nodes from one location to other location for a desired task. So for that we need mobilizer as a component in the wireless sensor node.